Now, have you ever looked at
how it works.
planes and gone, I could fix this? I just don't have the
Yeah.
time. Too busy
I
making
have a design for a plane.
You do?
Yes.
A better design?
I mean, probably. I think it is. Yes.
Who have you talked to about this?
And I've talked to friends.
Friends?
Friends and
I'm your friend.
girlfriends. And
You can tell me. What do you got? What's going on?
Well, I mean, the exciting thing to do would be some sort of electric vertical takeoff and landing supersonic jet of some kind.
Vertical takeoff and landing, meaning no need for a runway. Just shoot up straight in
Yes.
the air and then. Ooh. How would you do that? I mean, they do that on some military aircrafts, correct?
Yes. The trick is that you have to transition to level flight, and then the thing that you would use for vertical takeoff and landing is not suitable for high-speed flight.
So you have two different systems.
I've
Vertical
thought
takeoff
about this
and
quite
landing
a lot.
system.
I've thought about this
Okay.
quite a lot. The interesting thing about an electric plane is that you want to go as high as possible, but you need a certain energy density in the battery pack because you have to overcome gravitational potential energy. Once you've overcome gravitational potential energy and you're at a high altitude, the energy you use in cruise is very low, and then you can recapture a large part of the gravitational potential energy on the way down. So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So once you can get high, the way to think about a plane is it's a force balance. So the force balance. So a plane that is not accelerating is a neutral force balance. You have the force of gravity, you have the lift force of the wings, then you've got the force of the whatever thrusting device, so the propeller or turbine or whatever it is, and you've got the resistance force of the air. Now, the higher you go, the lower the air resistance is. Air density drops exponentially, but drag increases with the square. An exponential beats a square. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
I'm too stupid for this conversation.
It makes sense, though.
No, I'm sure it does. Now, when you think about this new idea of designing, I mean, when you have this idea about improving planes,
Mm-hmm.
are you going to bring this to somebody? Or you just chuck
Well,
this
I have a lot on
around?
my plate.
Right, that's what I'm saying. I don't know how you do what you do now, but if you keep coming up with these, but it's got to be hard to pawn these off on someone else either. Hey, go do a good job with this vertical takeoff and landing system that I want to implement to regular planes.
The electric airplane isn't necessary right now. Electric cars are important.
We need
Solar
some sort
energy
of,
is important. Stationary storage of energy is important. These things are much more important than creating electric supersonic VTOL. Also, the planes naturally, you really want that gravitational energy density for an aircraft, and this is improving over time. So, it's important that we accelerate the transition to sustainable energy. That's why electric cars, it matters whether electric cars happen sooner or later. We're really playing a crazy game here with the atmosphere and the oceans. We're taking vast amounts of carbon from deep underground and putting this in the atmosphere. This is crazy. We should not do this. It's very dangerous. So we should accelerate the transition to sustainable energy. The bizarre thing is that obviously we're going to run out of oil in the long term. There's only so much oil we can mine and burn. It's tautological. We must have a sustainable energy transport and energy infrastructure in the long term. So we know that's the end point. We know that. So why run this crazy experiment where we take trillions of tons of carbon from underground and put it in the atmosphere and oceans? This is an insane experiment. It's the dumbest experiment in human history. Why are we doing this? It's crazy.
Do you think this is a product of momentum, that we started off doing this when it was just a few engines, a few 100 million gallons of fuel over the whole world, not that big of a deal, and then slowly but surely over a century it got out of control, and now it's not just our fuel, but it's also fossil fuels are involved in so many different electronics, so many different items that people buy. It's just this constant desire for fossil fuels, constant need for oil, without consideration of the sustainability.
The things like oil, coal, gas, it's the easy money.
Right.
It's easy money. So,
have you heard about clean coal? The president's been tweeting about it. It's got to be real. Clean coal, all caps. Did you see? He used all caps. Clean coal.
Well, it's very difficult to put that CO2 back in the ground. It doesn't like being in solid form.
Have
it
you
takes
thought
a lot
about
of energy.
something like that? Like some sort of a filter, giant building-sized filter, sucks carbon out of the atmosphere? Is that possible?
No, it doesn't. Not possible.
No?
Nope, definitely
So
not.
we're fucked.
No, we're not fucked. I mean, this is quite a complex question.
Right.
We're really just the more carbon we take out of the ground and add to the atmosphere, and a lot of it gets permeated into the oceans, the more dangerous it is. Like I don't think right now. I think we're okay right now. We can probably even add some more, but the momentum towards sustainable energy is too slow. Like there's a vast base of industry, vast transportation system. Like there's 2.5 billion cars and trucks in the world. So and the new car and truck production, if it was 100% electric, that's only about 100 million per year. So it would take, if you could snap your fingers and instantly turn all cars and trucks electric, it would still take 25 years to change the transport base to electric.